When you look up at the night sky, surrounded by millions of stars like quiet points of light, have you ever wondered, what is the most powerful thing among all that silent motion? Not the kind of power you see in action movies, where everything explodes and everyone screams, but a real kind of power, the kind that can change everything, shape worlds, bend space and time, or simply exist. And that alone is enough to make the universe bow. Maybe you think of a black hole where even light gets swallowed, or a supernova so blinding it makes millions of other stars fade. Maybe you think of a force, gravity, nuclear energy, or even time itself, something no one can resist. But maybe the most powerful thing isn't out there in the vastness of space. Maybe it's much closer, in every cell, every memory, every feeling, in the sigh of someone remembering, in the look that realizes it's fallen in love, in a whispered goodbye, carried on brainwaves, spreading into choices, actions, fate. Tonight, I invite you to take a walk with me through another kind of universe, not one of maps or equations, but one made of questions. We'll explore what might truly be the most powerful force of all, from physical forces to things we can't even see. And maybe, just maybe, by the end of the journey, you won't want to answer that question anymore. Because maybe the question itself is the most powerful thing of all. There are places in the universe where light, the fastest, most untamed thing we know, is no longer free. Places where space-time itself, the invisible stage on which all motion occurs, suddenly wrinkles like a crumpled rug, folding in around a point so dark we can't see anything anymore, only an emptiness that feels almost hypnotic. These are the places that gave birth to a name that silences both scientists and poets alike: black holes. When you look at a black hole, you're not really seeing anything. You're seeing nothing at all. Perfect darkness. Not because light is missing, but because light can't escape. Every ray, every signal, every physical whisper is trapped behind an invisible boundary known as the event horizon. And once something crosses that boundary, it can never return, not even information. Sounds surreal? And yet, black holes are among the most precisely described structures in modern physics. They aren't holes in space. They are presences, compact, unimaginably dense points where mass collapses under its own gravity until everything is crushed into a single, invisible point called a singularity. We used to think the universe was upheld by order, planets circling stars, stars circling the centers of galaxies. But then, thanks to a wild-haired scientist with an imagination ahead of his time, Albert Einstein, we learned that space-time isn't a fixed stage. It's soft. It bends. And if there's too much mass in one place, it bends so much that even light can't find a way out. Imagine a star, dozens of times more massive than our sun, burning through its fuel. In its final moments, gravity is no longer countered by the outward push of fusion. What follows is a collapse faster than a blink, where the star's core caves in on itself. There's nothing left to hold it back. And so, a black hole is born. These black holes might be as small as a stone, but contain several times the mass of our sun. All the matter, all the energy, all the memories of that former star, crushed into a point with no surface. Something that no longer behaves like anything in physics we once knew. And strangely enough, the universe seems to be full of them. At the center of nearly every galaxy, including our Milky Way, lurks a supermassive black hole, millions or even billions of times the mass of the sun. It reigns like a silent, invisible heart, orchestrating the cosmic dance around it. They don't need to speak. They don't shine. They don't announce themselves. They just exist. And their presence alone is enough to make everything else revolve. You might ask, so what is the power of a black hole? This power doesn't lie in action. It doesn't shoot beams or tear things apart. It simply attracts. Not in the poetic sense, but in the literal one, gravity. Anything that comes close is drawn in, slowly, then rapidly, then beyond return. In Newton's world, we thought of gravity as a pull like an invisible rope between two objects. But Einstein said, space-time curves, and matter merely follows those curves. A black hole is where the curve becomes a cliff. Even time, something we once believed to be steady and constant, slows down near a black hole. To a distant observer, anything falling into a black hole seems to freeze at the event horizon, forever and yet never quite, as if time itself gets confused. Physicists love a good thought experiment. For instance, if you stand near a black hole and look at a friend flying away from you, their time would appear to move faster, while yours slows down. But if you were the one flying away, you'd see the opposite. Who's right? The answer is both. Because in the world of relativity, truth isn't a rigid block. It's a rippling surface, shifting with each observer's motion and position. And there's something quietly terrifying. Black holes don't just swallow light, they swallow information, at least in the classical model. Throw a book into a black hole and every letter, sentence, idea vanishes, no trace, and that sparks one of the greatest paradoxes in modern physics. Does information truly disappear? If it does, the laws of physics break down. If it doesn't, where does it go? Stephen Hawking once proposed that black holes aren't entirely black. They emit a faint form of radiation, Hawking radiation, and gradually evaporate over time. But if that's true, what happens to everything that fell in? Some say black holes are gateways to other universes. Others suggest the information isn't lost but somehow encoded on the event horizon surface, like a 3D picture compressed into 2D. Some even argue that black holes don't actually exist. They're just the edge of our understanding, painted in shadow. And in facing something like this, where light halts, time bends, and physics hesitates, we begin to see that black holes aren't just scientific objects. They're symbols. Symbols of the unreachable, the unseen, the unknowable. A black dot on the perfect canvas, where all of humanity's guesses must bow in humility. Maybe the power of a black hole doesn't just come from its mass or its pull, but from its silence. In a universe full of noise, of bangs, bursts, and brilliant lights, black holes simply are. No declarations, no demands, just an undeniable presence. An emptiness that weighs as much as the cosmos. And maybe that's our first real definition of true power. Not the one that shakes everything, but the one that moves nothing, yet makes everything revolve. If you drop a leaf, it falls to the ground. An apple detaches from its branch, a river flows to the sea, a rock tumbles down a hillside. All of them do the same thing without being taught. Whether you're on a remote mountaintop, in the middle of a crowded city, or floating in outer space, there is always something pulling you downward, toward the center, toward some invisible point you don't even have to see. That's gravity, the weakest of the four fundamental forces of nature, yet the only one you can feel everywhere, all the time, without stepping into a lab. You can't see the strong nuclear force holding protons together. You can't see the electromagnetic force that makes magnets stick to your fridge. But gravity, you live with it. Every step you take, every breath you draw, every chime of a clock, all of them are kept grounded by it. And yet, gravity is weak. If you pick up a pen, just lift it from the floor, you, with a bit of muscle, and will have overcome the pull of an entire planet. A planet weighing 6 sextillion tons. And you, a fragile little creature, just defeated it with your thumb. But weak doesn't mean unimportant, because gravity, as thin as a whisper, never fades, never shuts off. It needs no power source, no contact, and most importantly, it acts on everything with mass, no matter how big or small. A single proton and a galaxy of hundreds of billions of stars both obey the same law. If you launch yourself into space, leaving your home planet behind, you won't escape gravity, you're just falling forever without hitting anything. Earth, the moon, the sun, the planets, the satellites, the comets, the galaxies, they're all falling around each other, falling along gentle curves in spacetime that Einstein called geodesics, the most natural paths matter can take when undisturbed. Before Einstein painted his vision of curved spacetime, people thought of gravity as an invisible string tugging between two things. Newton, inspired by a falling apple, wrote an equation so elegant, the world stood in awe. In it, he described gravity as a force proportional to mass and inversely proportional to the square of the distance between objects. That very equation helped us put satellites into orbit, send ships to the moon, and precisely predict planetary motion for centuries. And yet, Newton didn't know why gravity existed. He only observed that it worked and described how it worked. He even admitted, "I frame no hypotheses about its cause." Then came Einstein, and instead of asking, "How does this force pull?" he asked something else. What if there's no pulling force at all? Just the ground curving beneath your feet? In general relativity, Einstein proposed that matter bends spacetime, and that bend directs how things move. An apple isn't being pulled. It's following the curve of spacetime warped downward by Earth. The moon isn't tethered to Earth by a string. It's gliding freely along a curve that loops around our planet. The universe was no longer a flat stage with invisible strings. It became a silk sheet where massive objects sink the fabric and everything else slides into the curves created by mass. And from that came something beautiful. Gravity isn't loud. It doesn't make noise, doesn't spark, doesn't startle. But it is the conductor of the cosmic symphony. Without gravity, no planets would exist. Cosmic dust would never gather into stars. Without stars, there would be no light, no heavy elements, no land or water, no trees, no people. No you. And it doesn't live only in physics. Gravity lives in poetry, in music, in feeling. We say we're drawn to someone as a metaphor, but it's actually an echo of the same force that's held you to the ground since the day you were born. In a way, gravity is the whisper of connection. Every atom in your body is quietly tugging on every other atom, everywhere. And you are being pulled toward the center of Earth, but also by the moon, by the sun, and by millions of distant galaxies you've never even seen. You are the temporary center of billions of gentle pulls, and you don't even realize it. If you go farther, much farther, beyond the solar system, beyond the galaxy, you'd see galaxy clusters drifting like stones across a sea of spacetime. And between them, there are near-empty voids, where gravity feels lost, but never disappears. There are places where gravity is so strong that light itself can't escape, as we saw in the last chapter. But there are also places where it's just a silent kiss between a planet and its moon, where spiral orbits sketch out voiceless songs. Sometimes we try to go against gravity with rockets, planes, balloons, but eventually we return, because gravity isn't a tyrant. It's patient. It doesn't force, it waits. So what makes gravity a great force? Not its strength, but its reach. Not its violence, but its unwavering presence. Not the way it destroys, but the way it preserves. It is the hinge of celestial systems, the spring of cycles, the invisible hand that steadies every spin. If you watch a child jumping on a playground, an astronaut orbiting Earth, or a galaxy slowly twirling in the dark, you're seeing gravity in its purest form. Silent, steady, unrelenting. Maybe you've never thought about it when you walk, but it's been there since the universe began, and it will be there until all light fades. And so we end our chapter on gravity, the fragile force that never goes away. It doesn't shout for attention. It doesn't need proof to be believed. It only needs to be what it is, a quiet presence, but one we cannot do without, like the heartbeat of the cosmos that never stops. Maybe real power doesn't belong to the one who shouts the loudest in the room, but to the one who says nothing and still makes everyone turn. If you could shrink down, really shrink, smaller than a strand of hair, smaller than a cell, so small you pass beyond atoms, you'd reach a strange world, the world of the nucleus. And deep within the heart of all matter lies a force so powerful it borders on the unimaginable, the strong nuclear force. It's a force you've never felt directly, yet it's present in everything you've ever touched, seen, or thought about. It doesn't pull planets. It doesn't make you fall to the ground. But it's the reason matter exists at all. Because without it, atoms wouldn't have nuclei. Without nuclei, there'd be no elements. Without elements, no molecules. And without molecules, well, you get the idea, there would be nothing. Imagine peering into the nucleus of a hydrogen, helium, or uranium atom. Inside, protons are packed tightly together, all carrying positive charge. According to classical electrostatics, like charges repel, and protons? They're all positively charged. They shouldn't be able to exist together in such a tiny space without flying apart, like rubber balls stuffed into a matchbox. So why are they still there, sitting side by side, not exploding? Why don't all nuclei just fall apart? The answer is, there's a force stronger than electric repulsion, strong enough to overcome that natural push and hold everything together. That's the strong nuclear force. It's the universe's glue, keeping the smallest building blocks from falling apart. It doesn't shine, it doesn't boast, but it's millions of times stronger than gravity. In a world so tiny it defies imagination, it reigns supreme. Here's the strange part. This force only works over incredibly small distances. Only when particles are within less than a femtometer, a millionth of a billionth of a meter, does the strong nuclear force kick in. It's like a super powerful latch. Too far and it vanishes, close enough and it locks tight. When protons and neutrons are within that range, the strong force between them forms a protective shield, keeping the nucleus from breaking apart. It not only resists electric repulsion, it stabilizes the entire structure of matter. That's why atoms can last for billions of years. Because deep inside, a silent guardian is always on duty. But like anything powerful, the strong force has two sides. In nature, when a nucleus gets too large, like in uranium or plutonium, it becomes unstable. The protons push each other too hard, and the strong force can't hold them all. The result? The nucleus decays. And when that happens, a small amount of mass is converted into energy, very small but very large. You've heard Einstein's famous equation, E equals mc squared. That's the formula for turning mass into energy. And in nuclear decay, it comes to life. This is the principle behind nuclear weapons. A handful of matter, no bigger than a fist, can unleash an explosion capable of leveling a city. The same principle, when controlled, powers nuclear reactors, providing energy for millions of people without a drop of oil or gas. And beyond that, it's also how stars shine. In the core of the sun, billions of nuclear fusion reactions occur every second, where light nuclei crash together and fuse, releasing heat and light. The very warmth you feel when sunlight touches your skin, that gentle light you see each morning, is the result of an incredibly tiny, incredibly powerful battle happening inside a star over 150 million kilometers away. You might think, how can something so small you can't even see it be a candidate for the most powerful thing in the universe? But remember, power isn't just about scale. It's about impact. And nothing has more impact than the strong nuclear force. It's in every atom you're made of. It literally holds you together. It powers the stars in the sky, the candle on your desk, and the atomic bombs of history. It proves that in the smallest realms of existence, the greatest power may be hiding. The subatomic world, where protons, neutrons, and quarks rule, doesn't behave like our everyday world. It defies intuition. Particles don't have fixed positions. They exist as probabilities. Forces don't come from ropes or rays, but from exchanges of particles called force carriers, in this case gluons, the subatomic glue. Gluons, from the word glue, are fundamental particles believed to transmit the strong force between quarks inside protons and neutrons. They have no mass, no charge, and they never travel alone. They constantly interact with one another, forming a wildly complex network inside each proton. If you think the planets and stars move in a chaotic yet logical dance, the particles inside an atom are even more chaotic and even more wondrous. They don't follow neat orbits, but clouds of probability. No defined paths, just a music with no notes, only frequencies. And within that music, the strong force is the invisible conductor. Every instrument follows its lead. It doesn't need to be loud, just precise. It doesn't stretch across the cosmos like gravity, or bend space and time like black holes. But within its realm, it is king. And without it, the world would have no structure, no light, no atoms, no stars, no newborn baby crying its first cry, no mountain stream trickling over stone, no scientist sitting in silence over a sketch. In the end, the most powerful thing isn't always what you can clearly see. It's what, if missing, would make everything else fall apart. The strong nuclear force, through its silence and near-infinite precision, holds everything in its rightful place. It doesn't destroy, it doesn't create, it holds. And sometimes to hold is the greatest act of all. Like a teacher quietly standing behind a student. Like a pillar no one sees, but if removed, brings the whole house down. If black holes bend everything toward them, and gravity patiently sculpts the motion of the universe, then the strong nuclear force is the quiet craftsman, working in the dark, with hands that never tire. Inside every atom lies a secret, a compromise, a negotiation between forces. And without the strong nuclear force to mediate, nothing we call matter would survive. Maybe that's why it deserves to be called one of the greatest powers in the universe. Not because it's loud, but because it's so essential, it cannot be absent. Close your eyes for a moment. Feel the warm sunlight sneaking through the window, touching your skin. That gentle light actually began its journey 8 minutes ago. It was born in a place no one has ever touched. A place so hot that matter melts out of its form, where atoms are stripped bare, smashed apart, fused together, and then broken again, the core of a star. That is where fusion lives. Fusion isn't fire as you know it. It doesn't burn with oxygen, release smoke, or need a match to ignite. But it's what has lit up the sky since the dawn of time. It needs no wood, no oil, only light atoms and the universe's endless patience. It is an ancient flame, never rushing, never fading. Slow, steady, and terrifying. Without it, there is no Sunday. Without the sun, no trees. Without trees, no you. At the heart of the sun, where temperatures soar above 15 million degrees Celsius, pressure is so intense that all barriers between atomic nuclei collapse. Hydrogen nuclei, which normally repel each other due to their positive charges, are forced so close together they have no choice but to merge. When two hydrogen nuclei fuse into one helium nucleus, a small part of their mass is lost. Not vanished, but transformed into energy by that simple yet legendary equation, E equals mc squared. It's just a tiny bit of mass, but when multiplied by the speed of light squared, an enormous number, it releases a staggering amount of energy. The miracle is that reaction happens millions upon millions of times per second, constantly, tirelessly, flawlessly. And the result? Light, heat, the very thing you're feeling right now, whether you're sitting on a chair, curled up in bed, or walking down a quiet autumn street. It's a gift from a reactor over 93 million miles away. Fusion isn't just the sun's engine. It's the soul of every star. From tiny stars that burn quietly for billions of years, to massive ones that blaze brilliantly and then explode in an instant, they all run on the same thing: nuclear fusion. Inside them, light atoms collide, combine, and release energy, and that light travels across space, pierces through cosmic dust, and touches our eyes. When you look up at the night sky and see a tiny dot of light, you're seeing the glow of a fusion reaction that happened years, maybe centuries ago. Sometimes you're looking at light from a star that no longer exists. That light keeps traveling on, like a late farewell from someone who left long ago. Fusion is life, but it's also the end. When a star runs out of fuel, when hydrogen is no longer enough to burn, that fire slows, the core begins to collapse. For massive stars, the finale can be a brilliant supernova, leaving behind a black hole or neutron star. For smaller stars like our sun, it shrinks more gently, becoming a quiet white sphere, a white dwarf, still glowing for a while before fading forever. Whether it ends in a blaze or in silence, every death follows a simple rule. Energy cannot be created or destroyed, but the place that makes it has limits. Fusion is a constant negotiation between gravity, which wants to pull everything inward, and the fusion reaction, which pushes outward. When the two forces are balanced, the star lives. When they aren't, the star dies. But that death begins something else. It's in supernova explosions that heavy elements, iron, gold, uranium, are formed. That gold ring on your hand? It might have once been the core of a star that exploded billions of years ago. The iron in your blood? From the same place. Your body, flesh, bones, blood, is the legacy of fusion reactors that burned out before Earth even existed. You are stardust. Not metaphorically, literally. We've tried to recreate that reaction here on Earth. If we can control fusion, humanity would have a clean, sustainable, nearly limitless source of energy. But it's not easy. To get two nuclei close enough to fuse, we need temperatures of hundreds of millions of degrees. And to maintain that environment, we need extreme magnetic fields or intense collision events. Projects like ITER and tokamak reactors are trying to do just that, hold a little bit of star fire here on Earth. And when we watch those reactions in a lab, surrounded by thousands of sensors and superconducting magnets cooled to near absolute zero, we realize what stars do naturally, in the dark silence of space, is something we need all our intelligence, technology, and hope just to imitate. Fusion is like the quiet heartbeat of the universe. Without it, the cosmos would be just a cold cloud of nameless particles. But because of it, everything is lit. Because of it, life exists. And because of it, even death becomes the beginning of something new. You may never see fusion with your eyes. It leaves no mark on the ground. But it leaves behind everything else. Trees grow because of sunlight. Food exists because of photosynthesis. Humans live because energy comes from the sun. You don't have to know it to be affected by it. But once you do, you'll never look at sunlight the same way again. Because every ray of light you see is a letter from the distant past. A message from burning cores that never stop glowing in the dark. Maybe the most powerful force in the universe isn't an explosion, isn't destruction, but stability. A reaction that has continued steady and sure for billions of years. Needing no control, needing no command. It only needs to exist, and everything you know will follow. That is the power of the fire within stars. The fire the universe lit and never let go. There is something inside you, so small it can't be seen, yet so powerful it determines the color of your eyes, the shape of your smile, the length of your pinky finger, and even things you never thought could be coded. Not in any human language, but in one more ancient than anything ever written. The language of life. That language is called DNA. A double helix twisted like a staircase, tucked neatly inside every tiny cell. A cell, something you can't see without a microscope, holds a code over 2 meters long, coiled like a scroll of sacred text, silent but radiant. And the strangest part, every single one of your cells contains that scroll. A complete copy of you in every corner of who you are. You don't have to think about it for it to work. You don't have to read it for it to function. It simply performs its task, keeping you. From the moment you were a tiny embryo, just a cluster of dividing cells, DNA has been the quiet blueprint. It told this cell to become an eye, that one to become a heart. It decided the first beat of your heart, and then, without stopping, kept everything going until the very last. DNA didn't come from humans. It is older than us, deeper than the imagination of any writer. It began with the first flickers of life, maybe in droplets of ancient ocean, where random molecules bumped into each other and found a way to copy themselves. A simple strand, a tiny error, then a mutation, and over billions of years, those molecular sequences became the map of every living thing that has ever existed. Every fish, every oak tree, every bug, every person. No one wrote DNA, but somehow DNA learned to write itself. It taught itself to say, this is how you make a lung, or this is how an eye sees red. It doesn't know what it's doing, but it does it anyway, simply because the strands that work better survive, and the messy ones fade away. An evolution without intention. A mind with no brain. And maybe the strangest thing, DNA doesn't just write life. It carries the memory of life. When you eat an apple, you're swallowing thousands of blueprints, copied through generations of that tree's ancestors. When you look at a cat, you're seeing a biological history that stretches from primitive animals to the lazy creature curled on your sofa. And when you look into your own DNA, you see traces of your ancestors and theirs before them. Parts of your DNA match a mouse. Some match a fish. Some match bacteria. You are not just you. You are a living museum of all life on this planet. DNA doesn't work alone. It's not a quiet librarian keeping books in order. It's a choreographer. It tells cells to make proteins, which then build every part of your body. Skin, hair, nails, blood, enzymes, hormones, all coded from a sequence of just 4 letters. T, C, and G. Only 4, but through infinite combinations, they wrote you, and like any long piece of writing, sometimes there are mistakes. A letter goes missing or is added or swapped. But those mistakes, called mutations, are the fuel of evolution. If every strand of DNA copied perfectly, life would never change. But because there are mistakes, and because some mistakes help, life can adapt, survive, and keep going. A fish can swim farther. A tree can survive drought. A human can dream differently. Today, we're starting to understand this language. We can read a person's entire genome in a matter of hours. We can find the genes that cause disease, that shape your height, your hair color, even your mental tendencies. We're stepping inside ourselves, not through a mirror, but through a string of code. But the big question remains. If you knew your entire DNA code, would you really know who you are? Because DNA can write your body. But what about your soul? Is the self also code? Maybe. Part of what you feel as you might be genetic. But the rest, the memories, the sadness, the joy, the love, isn't in a T, C, or G. It's written in experience, in randomness, in things that can't be duplicated. Some call DNA God in molecular form. Others call it a script. But whatever you call it, the truth is this. Inside you is a sequence of letters, quietly working since before you knew you existed. And that sequence isn't just in you. It's in every living thing, like a shared poem of life, translated into billions of forms, but always written from the same source. Maybe the most powerful thing in the universe isn't the explosion of a supernova, not the nuclear force inside an atom, but the ability of one small molecule to silently create a laughing child, a remembering adult, an old person telling a story, an invisible chain yet solid as stone, a quiet beat yet echoing through all of history, a machine with no gears, no engine, but one that built an entire world. And within you, that chain still continues, whether you know it or not, whether you notice or not. It doesn't need thanks. It doesn't need to be remembered. It just needs to do its job, because that is how life and you go on. Some things in the universe are clear, solid, undeniable. A star explodes, radiating a light so brilliant it drowns out everything around it. A black hole swallows space as if time itself is being torn apart. Gravity holds planets in orbit, silently and without touch. But then there is something that can't be seen, can't be measured, can't be written into any equation. It exerts no force, has no mass, no color, no glow. And yet it cannot be extinguished. That something is consciousness. You're hearing these words through it. Not with your ears, not with your eyes, but with something else. Something deeper, hazier, floating somewhere between sensation and thought. No one has ever seen consciousness or held it or stored it away, but it's here. You wake up in the morning and simply know that you exist. You don't need proof. You don't need logic. You just know. That's where consciousness begins. People often ask, what's the most powerful thing in the universe? And the answers tend to circle back to black holes, explosions, gravity, nuclear energy. But no one ever asks, is there something stronger than physics itself? Something that doesn't touch matter, but still shapes everything matter creates? If such a thing exists, it has to be consciousness. Consciousness can't lift a rock, but it can command a hand to do it. It doesn't burn fuel, but it can invent an engine. It has no voice of its own, but it can write words that change history. From a blurry thought in a primitive brain, to the first constitution, to the whisper, I love you, in the dark, these are all children of consciousness. You could be standing in a forest, listening to the wind brushing through the leaves, watching sunlight spill through the canopy, and suddenly wonder, why do I feel this? There is no formula to explain that sensation. No law that can define that emotion. Because consciousness is not a physical phenomenon in the way we understand. It's not merely a chemical reaction, not just electricity running through neurons. It is the unanswered question, the mirror into which physics stares and sees no reflection. Many believe that consciousness arises from the brain, a structure so complex that no supercomputer has been able to fully simulate it. But if you ask, what exactly in the brain makes us aware that we are alive? You'll likely get a shrug. We know a lot. We know the brain processes information. We know this region handles language, that one handles movement. But knowing, feeling yourself feel, that's different. That's not a calculation. That's an inner phenomenon, private and unshareable. You can describe sorrow, but no one else will feel exactly your sorrow. You can write about being in love, but only you know what your love feels like. Maybe you're lying in bed, staring at the ceiling, listening to music or rain, and suddenly realize that you are here, not just as a body that exists, but as a you, a self that is observing, a point of light in the dark sea of matter. No one knows where that self begins, or where it might end, but it is here, asking questions, feeling, remembering, longing. Consciousness might be a beautiful accident of evolution, a byproduct of a brain that grew too fast. But if that's the case, why is it so beautiful? Why can it create painting, music, poetry, philosophy, things with no survival value, yet which make life feel worth living? Why can a poem written by someone in the 13th century still make you cry? Why can a painting made with nothing but color and lines make you feel like you're staring into someone's soul? Only consciousness can do that. The universe doesn't need consciousness to exist. But once it appears, it gives the universe meaning. A cold, rocky planet drifting through space is just a rock. But when a conscious being looks up at the sky and asks, "Why am I here?" that planet becomes a home. A wall in your house is just cement until you hang a photo of someone you love. The universe is the same. It's just energy, matter, space, time until someone sees it, names it, and feels it. That's the strange power of consciousness. It doesn't bend light or warp orbits, but it bends the worldview. It can help someone survive the impossible just by believing. It can drive a scientist to spend a lifetime chasing a virtual particle. It can keep someone alive in your heart long after they're gone. And because of that, it doesn't have to be as strong as nuclear energy, because it's what gave rise to the very dream of nuclear energy. When you're sitting alone, silent, doing nothing, you still have consciousness. It still flows like an underground stream. When you dream, it doesn't disappear, it transforms. When you meditate, you don't lose it, you dive deeper into it. No one else can see your consciousness from the outside, but you know it's real, because you are it. There might be billions of planets, millions of star systems, endless black holes and radiation and physical laws across the cosmos. But if no being knows that the universe exists, then what does it all mean? That question has no scientific answer. Yet it sits at the heart of every philosophy, every religion, every poem ever written. Consciousness is where physics becomes story, where space and time are filtered through emotion, where numbers become tears and equations become music. It's the one thing we can never fully describe, yet we use it to describe everything else. If you've ever looked into someone's eyes and felt like you were seeing an entire world inside them, it's because you touched their consciousness, not their skin, not their voice, but the self inside them seeing the self inside you. And maybe, in a vast, cold, indifferent universe, the most powerful thing isn't the heat of the stars, or the pull of gravity, or even time itself. Maybe it's a moment when two conscious beings meet, recognize each other, and fall silent together. Time doesn't knock. It doesn't enter the room, doesn't leave footprints, doesn't make a sound. But when you turn around, it's already there. It doesn't need your attention. It doesn't need to be named. It just keeps flowing, quietly, patiently. None of us has ever seen time with our own eyes, but we all know it's real. You feel it every birthday, every time a gray hair appears, every time you see a child who was crawling yesterday and is running today. Time is one of the strangest things humans have ever tried to understand. You can't touch it, store it, rewind it, or stop it. But everything you know, everyone you love, everything that has ever happened, all happened inside it. Without time, there would be no change. Without change, nothing would live. The universe would be a still photograph. No beginning, no end, no motion, no hope. When you were a child, time felt like a vast ocean, unmapped and endless. Summers stretched on like lifetimes. Waiting for a cake to bake felt like an afternoon with no end. But then you grew up. Time seemed to speed up. A week passes like a single breath. Spring arrives and disappears before you notice. The new year comes as if the old one had barely started. Someone once said, "Time is like a rubber band. When you're young, it stretches out. As you grow older, it snaps back." That feeling isn't an illusion. It's a truth shaped by your own brain and heart. There's no force you feel more deeply and are more powerless against than time. You can walk against the wind. You can avoid a current. You can resist gravity for a while. But no one can stop time. You can delay a decision, forget a sorrow, avoid a truth. But time will come, like a loyal friend without mercy. It makes everything fade. Colors dim. Memories vanish. People once close become strangers. Things that once mattered most turn unfamiliar. Not because you want to forget, but because time flows on and carries even the things you tried hardest to hold on to. And yet, it also heals. The pain that roared like a storm yesterday is now just a faint echo. The wound that once bled is now a scar. A word that once broke you is now a lesson. Time doesn't apologize. It doesn't explain. But somehow, it helps you understand that everything passes. Physicists once believed time was absolute. Newton described it as a steady current, never skipping a second, flowing from past to future without needing a witness. But then Einstein came along and said, "Time isn't absolute. It stretches, it bends, it slows down near black holes, speeds up at higher altitudes. Time isn't the stage where the universe plays out. It's part of the universe. It's shaped by matter, by gravity, by motion. That means a clock at the bottom of a mountain runs slower than one at the top. An astronaut on the space station ages more slowly than their twin waiting on Earth. Experiments have proven this. Not in sci-fi movies, but in laboratories with atomic clocks accurate to trillionths of a second. Time really does stretch. It's no longer a calm river. It's a restless surface, pulled by gravity, warped by speed. But even as it stretches, even as it bends, time still moves in one direction. From before to after, from cause to effect, from birth to death. Every equation in physics can be written in reverse. A ball flying up then falling down can be described just the same as when you rewind the video. But life can't. You can't remember the future. You can't relive yesterday. Each moment comes only once. And when it's gone, it doesn't return. Why is that? Why can't we go back in time? Is it because our minds can only remember the past? Or because the universe moves in a direction where chaos increases? That's where entropy enters, an abstract but powerful concept. It describes the level of disorder in a system. And the second law of thermodynamics says, entropy always increases. An egg falls and breaks on the floor, but you never see the shards come back together. Not because it's impossible, but because the odds are too low. The universe prefers disorder. And time is the name we give that growing chaos. You feel time not because you have a clock, but because you have memory. Without memory, every moment would stand still. You wouldn't know what came before, what came next. You'd live in an invisible present. But the brain keeps traces. It records, it retells, compares. And through that, you know that yesterday was different from today. That you once loved, once hurt, once lost. That you are changing, and you can't go back to how things were. Time may not be a force. It doesn't push you, doesn't pull you, but it exerts a pressure no one can resist. It makes you grow up, then grow old. Teaches you to let go, to cherish, to love what you have. It makes every moment precious, because you know it won't come again. Maybe you used to fear time, used to hate change, used to wish you could keep everything the same. But think again. Without time, you'd never heal, never meet new people, never have a tomorrow, never dream, never hope. Time is the reason you can begin again. It's the second chance. It's the promise that every wound will someday become a scar. And as you sit here, on a day that seems ordinary, you are in a moment that will never repeat. Even if you repeat the actions, repeat the words, time keeps flowing. And you flow with it, gently, quietly, unstoppably. But you don't need to hold it back, because that's exactly what makes everything matter. When you try to define the universe using constants, fundamental forces, energy, mass, and light, you come very close to the physical essence of everything. But then, like a tiny drop falling into a still lake, something doesn't quite fit. Something that isn't in any formula, doesn't follow any law, can't be measured, can't be repeated, and can't be controlled. Something that can make a person laugh alone in the middle of the night, cry silently in a crowded room, or throw everything aside just to be with someone. That is love. There's no physical force called love in any textbook. No arrow in a quantum physics diagram that connects one heart to another. No Maxwell, Schrödinger, or Einstein equation can predict that you'll miss someone on a rainy afternoon. But love exists, and it exists fiercely, persistently, relentlessly. So much so that scientists, writers, poets, and philosophers alike have all been brought to their knees by it. Love isn't something you understand. It's something you feel. It doesn't need a reason, yet it fuels every action. It has no shape, but you can see it in a hand held, a glance exchanged, a sigh breathed. No one knows exactly why we love. Maybe it's a complex biological mechanism born of natural selection. Maybe it's just the brain processing chemical signals. But if that's true, why would someone be willing to sacrifice everything for another? Why can one person hurt for years over an unreturned feeling? Why, among millions, do you remember a single voice? Love isn't as strong as gravity. Can't pull planets together. But it can pull people close across distance, through time, even against reason. Love isn't as hot as a supernova, but it can burn away every doubt, every fear, and leave behind a strange, gentle light in your chest. Some people love without ever saying it. They just quietly walk beside each other, like two parallel planets that never touch. Others love with their whole lives, ready to give everything without expecting anything in return. Some love only briefly, like the wind, but even that can be enough to change someone forever. There's no common denominator, no formula. Every love is its own universe. When you look at an old photo and see the face of someone who once mattered, your heart might ache, even if your mind says it's all in the past. That's not weakness. That's the power of love. It doesn't vanish like numbers on a screen. It lives on in memory, in your cells, in the way you speak, laugh, breathe. A child doesn't need to be taught to love their parents. A mother doesn't need a reason to love her child. Love isn't learned, it's felt. It blooms from the deepest part of consciousness, a place science has yet to reach. Love may be the foundation of every great act of creation. The songs that make you cry, the paintings that hold you still for hours, the novels that keep you awake through the night, all carry within them a shadowy shape of love. Love for a person, for an idea, for a world that doesn't yet exist. And maybe love for loneliness itself. When an astronaut brings a photo of their family to the space station, that's love escaping Earth's orbit. When a soldier keeps a small letter in their pocket on the battlefield, that's love stronger than death. When someone, for no reason at all, simply shows up when you need them most, that's love needing no explanation. Love might be the only thing that drives humans beyond the instinct to survive. For love, people accept sacrifice. For love, they learn to forgive. For love, they fall and get back up. No physical force can do that. The universe would go on without love. Particles would still collide. Stars would still burn. Galaxies would still spin. But what would a universe without love be? A body with no heart. A poem with no rhyme. A song with no sound. Without love, no one remembers. No one tells stories. No one dreams. Love won't make you immortal, but it will make you feel truly alive. Every hug, every promise, every moment of waiting is proof that you are living, really living. And in this world, where everything changes, where nothing is certain, love might be the one thing that gives us the courage to keep going. You might not believe in love. You might have been hurt, disappointed, exhausted, but love doesn't disappear because of that. It's still there, waiting in a glance, in a gentle touch, in an unfinished letter. You can't choose when it comes, but you can choose whether to let it stay. And when you think about everything that's ever changed you, a book, a conversation, a walk in the afternoon, ask yourself, wasn't there, somewhere beneath it all, some form of love? Love doesn't need an explanation. It only needs to be felt. Like light doesn't need to be understood to shine. Like time doesn't need to be seen to be real. Love isn't a secret to be solved. It's something to be lived. And maybe in a universe that is cold, quiet, and indifferent, love is the reason you still look up at the night sky and whisper something, even when no one is listening. When the journey began, we were looking for something that seemed simple. The question at the start echoed like a distant voice among the stars. What is the most powerful thing in the universe? It sounded like the kind of question that demanded a short, measurable answer. Something that could be summed up in a number, a law, a phenomenon. But then, as with every journey that goes far enough, the destination turned out to be nothing like what we imagined. Because power, in the end, is not a unit. We've passed through realms where light disappears, where gravity reaches its absolute extreme, where time bends and space fractures. We've encountered black holes that silently consume everything in their path, without a word. They are so powerful they don't need to rage or prove themselves. Just by existing, they alter the fate of galaxies. And yet, no matter how immense, a black hole doesn't choose to love, doesn't write poetry, doesn't dream of an autumn afternoon. We also paused at the root of matter, where tiny particles are bound by something invisible, unfelt, yet stronger than anything outside. The strong nuclear force holds the universe together. It is a quiet power, but essential. We saw the energy pouring from fusion reactions, where stars burn endlessly for billions of years. These furnaces light up the long night, give rise to life, and mark the end of every beginning. Then we looked inward, into the double helix that carries billions of years of information, into the miraculous machine called DNA, a tiny molecule that can shape a face, a voice, a fear, a longing. No one tells DNA what to do, yet it knows. It writes trees, insects, humans, and even questions like this very one. We listen to the quiet voice of consciousness, where change is born without the need for matter, cannot be measured or counted. Yet consciousness is where everything begins, where memory is formed, where sacrifice gains meaning, where a person looks into the mirror and asks, "Who am I?" That question is not powerful in the usual sense, but it can shake an entire life. Then we stopped by the river of time, where everything flows without waiting, without explanation. No one can stop time, yet it never forces anyone to hurry. It simply flows and everything flows with it. Time doesn't argue or show off, but it heals every wound, raises every child, and turns every love into memory. And finally, we spoke of love, something invisible yet clearer than anything else, something that silences reason and makes the heart remember forever. Love doesn't need to win, yet it drives people to do the impossible. Maybe you don't think of love as a force, but if anything can help someone survive war, stay up all night to write a song, wait years just to meet one person, then that is exactly what it is. And now, looking back at everything, the question quietly returns. What is true power? Can we ever define it fully? Maybe not, because everything we've encountered is powerful in its own way. Some things bend the paths of planets. Some create life. Some exist without ever being seen. Some make people cry in silence. And perhaps that very variety is the first clue to a true definition. Power is not just the ability to cause change, but the ability to sustain something beyond oneself. A black hole is powerful because it traps light. DNA is powerful because it preserves life for billions of years. Consciousness is powerful because it creates questions. Time is powerful because it never stops. Love is powerful because it makes people believe in what hasn't yet happened. And when all of these exist together, not denying one another, not replacing one another, but weaving into a cosmic symphony, then true power may lie in that very connection. Maybe power isn't in each particle on its own, but in how they see each other. A black hole is strong, but it cannot feel. A molecule is strong, but it cannot remember. A law is strong, but it cannot dream. Only when they come together in a being that is conscious, that remembers, that feels, do they begin to make sense. And perhaps the strongest thing is the ability to give everything else a reason to exist. You once asked, what is the most powerful thing in the universe? And now maybe you have your own answer. Maybe it's unlike any other answer. Maybe it's a person you once met, a feeling you once had, a story you haven't forgotten, a small light inside you that no one else can see. The universe doesn't need to know if you have the answer, but you do, because in the endless silence of space, it is that question that keeps you awake. And when you ask it, when you search, you've already become part of that great force. You're still here, after all the journeys across the universe, through the hearts of stars, through the quiet pulse of DNA and the mysterious twists of consciousness. You're still sitting in the very place you began. The space around you might not have changed, but inside, something is no longer the same. We've been searching for the most powerful thing in the universe. But the further we went, the more we realized that true strength doesn't need noise. It doesn't need proof. It's not a blazing explosion in the dark, not a massive number in an equation. It might be a silence, a wordless glance, a question with no answer, a person who stays when everyone else has gone. Throughout this journey, there were moments when we encountered something both familiar and strange. Life, time, love, consciousness, all powerful in their own ways, none alike. But the one thing they all share is silence. They don't scream. They don't demand belief. They're simply there, like the sky, like breath, like a gentle memory you can't quite place the beginning of. You used to think power was what changed the world. But maybe the strongest thing is what holds the world together. The thing that makes you remember who you are and why you started. A light breeze may not topple a mountain, but it can make you stand still on a summer afternoon. A whisper may not drown out thunder, but it can take your fear away. A story that leads nowhere might still leave something deep and strange within you. The universe will go on. Stars will die. Black holes will swallow light. DNA will replicate, divide, then disappear. But what might remain is the story you just heard. A story that doesn't try to answer everything, but simply rests its hand on your shoulder and asks, can you feel it? Maybe power doesn't lie in the answer, but in the search itself. Not in the conclusion, but in the quiet after the final question. Not in what you've already learned, but in what you're still listening for. And if that's true, then you, sitting here quietly reflecting, letting these words drift through your mind, are part of the most powerful thing the universe has ever made. So, what time is it where you are? Maybe no one needs to know, but you do, because time is still moving, and you are still here, silent, strong, and present.